Hello, hello! Welcome to a great, grand, glorious day of pre-calculus. Today we're going to be talking about graphing inequalities and all the different ways that we can put things together to graph specifically linear inequalities. We're not going to get into all the other weird ones like absolute value inequalities, quadratic inequalities, or any of those other things. Just our nice little, there's only one variable floating around, inequalities. So put away your distractions, plot your notes, and here we go. So again, this recording is for day 2 of module 3. So module 3, day 2, and today's topic is solving inequalities. Please make sure that you put this on your notes up in the upper right-hand corner. So again, here's my paper, and I want something up here about solving inequalities just to help differentiate these notes from all of the other notes that you're taking in this class. Okay, so talking about inequalities, just kind of a recap of stuff and things. Here's a good classic inequality. X is greater than 3. When we go to graph things on a number line, so this gets graphed on a number line, boop, boop, boop. Here is 3. Miss Norton, like way back a long time ago, they told us you're supposed to put 0 in the middle, and then you do a 1, and a 2, and a 3, and then you do your stuff. Yeah, that works, that's fine. Technically, it's a number line, so you can zoom in on any portion of the number line, and it's still perfectly valid. So I usually don't do all that stuff. I just find the number that's interesting, and I write the number there, 3. So that's where we're starting on this particular number line. So I want x is less than 3, and we know that there's supposed to be a circly thing, and I'm supposed to draw an arrow, so if I want the values that are less than 3, one of the things that you can do sometimes, you can do test values, is 4 less than 3? No. Is 2 less than 3? Yes. So we want to go that way. Okay. But then are we supposed to fill in the circle? Yes or no? Sometimes we fill in circles. Sometimes we don't fill in circles. What do you do? And so just a quick little recap thing. We use what's known as an open circle is the terminology that we use. Open. What we mean is hollow when we say that. A hollow circle. And we use that for the symbols less than or also greater than. Less than or greater than. And then the other type of circle that you can have is you can have a closed circle. And what we mean when we say closed circle is we mean that it is filled in, not hollow, filled in. And we use those when we have a little bit of extra underneath the line. So usually, like one of the things that I kind of use when I'm thinking about these stuff and things is that if there's a little bit of extra on my sign, then I need to put a little bit of extra in my dot. In this particular case, we don't have extra stuff to put into the dot. So we don't have an extra thing, so we're not going to do something extra to the dot. We're just going to leave the dot alone, slowly back away, and we're done. Compare that to something like x is greater than or equal to 7. Graphing that guy on the number line. Here's 7. We're going to draw our dot. Do I want bigger or less than? Well, x is less than. Why did the inequality backwards on the first one? Oopsies. See, you guys aren't there to squawk at me. X is bigger than 3. Yes, 4 is bigger than 3. Derpa. Okay. I usually catch my mistakes. It takes me a minute. It's all good. So now I want x is less than or equal to 7. Oh, what a day. And because there's that little extra bit on the bottom here, we got less than or equal to, we're going to fill in the circle. So what a filled in circle means is that we are including 7. We are including 7. We actually get to 7. We are including the number. What this open circle up here means is that the number is not included in my interval. The number is not included in the interval. And so basically what this happens is we're going to get really, 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 really stinking close to 3, but we're not going to actually touch 3. We're going to be like that annoying sibling on a car ride that goes, I'm not touching you, I'm not touching you. And we're going to get really, really close. We're not going to actually touch them, or you kind of want to hit them because they're like right here in your face. But you know that if you do first strike, you're the one that's going to get in trouble, not them. All of that fun stuff. So yeah, we get really, really close to 3, but we don't actually touch it. So we get a hollow circle, which means get really, really close, but don't actually get inside here where the 3 is. Or we end up doing, actually it is less than or equal to, so please fill in the dot. So that's like the first big key ingredient that you need to know when it comes to solving inequalities. Okay, so we can do, we kind of went through, we did our first couple little examples. So that's the graphing aspect of things. So now we're going to talk about the solving thing, because we're going to solve and we're going to graph. We're going to do both of those things. And yes, it's just graphing on the number line, so it's, not too stressful. The one thing to remember about solving inequalities. So the one big thing is treat it like an equation. Treat it like an equation. So all the same rules for solving equations apply, except if you multiply or divide, because division is actually multiplication, when you get right down to it, dividing is just multiplying by a fraction. If you multiply, divide both sides, that's important, by a negative number, the same negative number, that might be a better thing, like the same negative number. If you're moving a negative number from one side of the equation to the other using multiplication or division, that's actually a better way to say this. By a negative number, flip the inequality sign. So what was looking like this is now going to look like that, or vice versa. So it's not like flip it top to bottom, because that doesn't actually change the sign. We want to go left to right, which way it's facing. Or if you had something like this, it would end up becoming something like this. And so, let's see, how did I say that? If you move a negative number via multiplication or division, move negative number via multiplication or division to the other side of the inequality side, flip sign. So that's the only time you flip the sign. Otherwise, it's just a little tiny equation. We're just trying to get the x by itself. And you kind of ignore the sign. The only time you pay attention to the sign is when you've got this multiplication by a negative number nonsense. Okay, so let's look at some examples, because, examples is where it's at. A picture's worth 1,000 words. All that joyful goodness. All right. First out of the bat, we got 3x plus 2 is less than negative 4. Okay, so again, we're going to ignore the sign. We're going to pretend like this right here is an equal sign, and we're just going to ignore it unless we hit our little sensor thing with we're moving a negative number from one side to the other via multiplication or division. Okay, so first move is always subtract. Get that constant thing over to the other side, and that's going to give me a negative 6, and then we're going to divide by 3. Oh, wait, dividing. Is that a negative number? No, it is not. It is positive. So, oh good. That means we don't have to do anything weird to the sign. And x is less than negative 2. And then, of course, we're going to graph this thing on a number line. Shoop. Here's our negative 2. We're going to open circle, because we don't have extra bits. We're not going to fill that in. And I want x to be less than 2. So, negative 1 does work. Negative 1 is less than negative 2. And we're going to head off in that direction. Okay, that was, examples. Not too bad, not too bad. All right, what's our next one? Let's see, that one's boring. Ooh, this one looks more fun. Negative 7x plus 8 is less than or equal to 1. Okay, so again, pretty straightforward thing. Move the constant to the other side because we're trying to get the x by itself. So negative 7x is less than or equal to negative 7. Okay, now we're going to divide both sides by, we're dividing both sides by a number. What number are we dividing both sides by? It's a negative 7. Oh no! We have to flip the sign. Ah! It's fine. It's fine. We just... There. See? Not that too bad. Now, some people really, really hate this flipping the sign nonsense. And so what they do is they kind of just avoid anything and everything that has to do with multiplying or dividing a negative number, because they're just like, changing the sign. It's dumb. I don't want to change the sign. So what they do instead is so we got negative 7x less than or equal to negative 7. So I'm going to plus 7x over here. And I'm going to plus 7. Basically, they're moving things from one side of the equation to the other, inequality to the other. And then, now it's all positive. I can divide this side by 7. And I can divide this side by 7. And I end up with this. You know what? These two inequalities are exactly the same. And it works out. over here, the green one is x is bigger than or equal to 1. And over there, the purple one, 1 is less than or equal to x. So same thing. When I go to graph these guys, they're both going to be, okay, let's go at 1. And I want the x values to be bigger than 1, or I want 1 to be less than the x values. So we're going to go that way. And because I've got that extra bit, I'm going to fill in my circle. There we go. There's my number line. Boom shakalaka. All righty. So that was kind of like our level 1 stuff thing. So let's go back up here. Level 1. Yay. Okay, level 2. Because, you know, why would we want to stick with level 1? Well, we can do level 2. Hello. So level 2. All right, what's going on with level 2? Oh, well, we're going to make things more interesting. We're going to put the letters on both sides of the inequality because all the letters on one side is just boring. So let's start off with something like 5v plus 1 is greater than 7v minus 17. All right, here we go. That's our stuff and our things. So, okay, so the really cool thing is when we have variables on both sides, we can always move things in such a way that we never have to deal with a negative number in front of the variable, and then we don't have to worry about the dividing flippy sign thing. Whoop, whoop. So I'm going to subtract 5v, because if I pull that thing over here, I end up with a positive 2v, and when I go to do the division bit to move things around, then I don't have to worry about plus 17. 1 plus 17 is 18, and my hands are going faster than my mouth. Silly me. Divide by 2, divide by 2. 9 is bigger than v. Wow, that looks so delightful. 9 is bigger than v, so I want the numbers, I want v to be over here. And I do want an open circle because doesn't have an extra stuff on it, so we're not going to put extra stuff in the circle. All right, that's not too bad. So that was, pretty straightforward. That one works out nice. So now we're going to get into a couple of cautionary tales of things to watch out for, because there's a couple of mistakes that people like to make when they're playing with this next example that we're going to look at. So we got 21 minus 3 times 5x plus 9 greater than or equal to 7. Boop. So that's our situation, right? So we have 21 is negative. Oh no, I'm multiplying by a negative. What do I do? No flippy the sign. No touchy that sign. That negative is getting distributed on one side of the inequality only. He is not moving from one side of the inequality to the other side of the inequality. The chicken is not crossing this road. We do not need to do anything to that sign. We're going to leave it alone. So that turns into negative 15x minus 27 is greater than or equal to 7. All right, combining up our like terms, negative 15x, 21 minus 27 is negative 6. It's greater than or equal to 7. I feel like something went wrong, but no. This is what's supposed to happen. This is what is supposed to happen. Oh, there's supposed to be an x right here. Bloop. You know what? It's fine. We'll just keep going with it the way it is. Bloop, bloop. We're going to end up with a fraction. It'll be fine. Plus 6, negative 15x greater than or equal to 13. Divide by negative 15, divide by negative 15. And x is less than or equal to, because we divided there, we're dividing both sides by a negative number. Here, we have to flip the sign around. Not up there at the top move, but down here at the bottom move. And that's going to end up being just negative 13 over 15. Doesn't matter where the negative ends up. It can be on the top of the fraction, the bottom of the fraction, right in front of the fraction. All those things means the exact same thing. So doing my number line, we have negative 13 over 15. I want x to be smaller than that. So we're going that way, and I'm going to fill in my circle because I've got extra bits. So those go into filling in the stuff and the things. All right, questions, concerns, comments, or queries. This would be a great time to like, hey, Miss Norton, la-da-da-da-da-da. I'm not going to respond today because I'm unavailable, but you can totally send me Teams messages, and then when I get around to having some free time in this evening, I can write you back. Okay, and we kind of already went through over an example like that, so I don't really feel like doing that again. What do we got over here? Ooh, let's see. Yeah, I think I'm going to do that one real quick. Am I? Nah, we've talked about the stuff and things. We're really good to go. Well, all right, I do want to talk about this guy because there's 2 other random cases that can happen. Probably not going to show up on the test. I don't think they show up on the homework, but just like the completionist in me insists on doing this. 4 times 6x plus 1. So that's going to be 24x minus 27 is greater than 24x plus 4. And doing our stuff and things, subtracting 24x, wait a second, negative 27 is greater than 4. The x's went away. So what do? Well, there's two possible outcomes when the x's all disappear like that. Either A, there is no solution, or B, all numbers work in this particular inequality. It doesn't matter what number I chuck in there for x, all of them work, so all real numbers. In this particular case, to determine whether or not this is an all real numbers or just nope sauce, we have to look at our inequality and determine, is this inequality true or false? So negative 27 is bigger than 4. Yeah, that's not true. So this is false. So that means we have no solution. And compare that to this one, 11x minus 4 is less than or equal to 6x minus 3 minus 5x. There's parentheses around the 3 minus 5x. We have 11x minus 4 is less than or equal to 6x, distributing the negative. We're multiplying by negative, but not both sides, so we don't touch that sign. Negative 3 plus 5x. So that gives us 11x minus 4 less than or equal to 11x minus 3 minus 11x minus 11x. And then that whole thing comes together and I have negative 4 is less than or equal to negative 3. Yeah, that checks out. Negative 4 is smaller than negative 3. It's more that way on the number line, right? So we have negative 3 here, negative 4 is there. That is smaller. Sweet. That is true. So my answer is all real numbers. How you draw the symbol for all real numbers, just in case we haven't talked about that, is you do 2 lines and then you do an R with 2 backs. And then that's the symbol for all real numbers. Yeah, so let me know if you have any questions, concerns, comments, or queries. Feel free to send me Teams messages. I will get to them when I get to them, and I will send you answers and responses. You are good to go to get started on the homework, and happy mathing!